This is Mrs. Naslin, and today we'll be doing Unit 1, Lesson 8, Factors and Prime Numbers. Our learning targets for today are, I can find factor pairs for given numbers and use them to determine whether a number is prime or composite. And I can write numbers as products of prime factors and use prime factorization to solve division problems. Now, there's a lot of new words in those learning targets, and as we dive in, we'll figure out what some of those words mean. So, first thing we're going to talk about is a factor pair. A factor pair for a number is two whole numbers whose product is that number. For example, 2 and 5 is a factor pair for 10. So basically, when I multiply 2 times 5, I get 10. Any two whole numbers that I multiply together to get a product are considered a factor pair. So the two numbers that you're multiplying are a factor pair. A number greater than 1 that has 1 in itself as its only factor pair is a prime number. Some prime numbers are 2, 5, 11, and 23. So really what that means is that a prime number means that there's no numbers that can divide into the number, none, except for 1 and the number itself. So let's take 5 for example. 1 divides into 5, and 5 divides into 5. Every other number doesn't divide into 5. I can't divide 2 into 5, I can't divide 3, I can't divide 4 into 5. It won't work. So 5 is considered a prime number. It's a number that no number divides into except 1 and the number itself. Now, the opposite of that is a composite number. A number that's greater than 1 that has one or more factor pairs is a composite number. Some composite numbers are 4, 12, 25, and 100. So a composite number is any number that more than 1 in itself divides into. So for example, 4. Well, I know that 2 divides into 4, so it is a composite number. 12. 1 divides into 12, so does 2. So does 3, so does 4, so does 6, and so does 12. So it's a composite number. Other numbers divide into it besides 1 and itself. The number 1 is neither prime nor composite. So 1 is just the number. It's not a prime number or a composite number. Other than that, every other number is either prime or composite. Now, factor fireworks show how a whole number can be broken down into a product of prime numbers. At the right are two factor fireworks for 12. This is a way of showing factors, is also called a factor tree. These are kind of fun. I like doing these. So if you take a look at this, we looked at 12, which we already decided was a composite number. We decided that there were multiple numbers that divide into 12. But let's see what numbers divide into 12. So the way you start a factor firework or a factor tree is you think of a number that divides into 12. So I'm going to say 4. 4 divides into 12, and it divides into 12 3 times. So on one side of the factor tree I do 4, say times, and then I do 3. And then I look at both of these numbers and I say, okay, does any number divide into 4? And yeah, 2 divides into 4. So I'm going to do another little split. And I write 2, and I write 2. And I go over here 3. Does any number divide into 3? Nope. So now 3 is considered a prime number because the only number that divides into 3 is 1 and 3. How about 2? Can you think of any number that divides into 2? Only ones that divide is 1 and 2. So 2 is considered a prime number. Now what if I chose something different? What if I said 12? Again, I'm starting with 12 as my whole number, but I decided to divide 2 into it instead of 4 or 3. So I divide 2 in it, and I think, okay, well, 2 times 6 is 12. And 2, there's nothing else that goes into 2, so I leave that one. But 6, I get 3, and I get 2. And again, nothing divides into 3, and nothing divides into 2, because those are both prime numbers. Now, what's really cool is it doesn't matter which numbers you choose. What you'll notice is that you still get the same prime numbers at the bottom. You get 2 times 2 times 3, or 2 times 3 times 2. And the order doesn't matter. They're exactly the same, just that the order is different. Okay? Now, it doesn't matter how large a whole number is, you can always break it down into a product of prime numbers. at the right is a factor firework for 2,100, 21,000, 21,000. So you look here, and they said, okay, I'll do 21 times 1,000. Then what goes into 21? Well, 7 and 3. And nothing goes into 7 and 3, so those both are prime numbers. And then for 1,000, they did 10 and 100. And 10 you could break up into 2 and a 5. And then 100 they broke into 10 and 10. And then they did 2 and 5 and 2 and 5. So no matter what factor pairs you start with, you will always get the same prime numbers at the end of the branches. Below are all 3 factor fireworks for 36, and 4 factors are at the bottom of each of the fireworks. So again, these are all 36. It doesn't matter what number you divide into 36. So this one they did 6 and 6, this one they did 9 times 4, and this one they did 3 times 12. And you keep breaking them apart. At the bottom, you're going to get the exact same prime numbers. Now, they might be in different order, but you'll notice there's 2 2s and 2 3s in each of these. 2 3s, 2 2s, 2 3s, 2 2s. So the same exact prime numbers are at the bottom. All right, so let's go ahead and practice a couple of these. All right, so we're going to practice these factor fireworks. It'd be great if you grabbed a whiteboard or a sheet of paper and you practiced along with us. In a few minutes, I'll have you do a couple on your own as well. So let's try 16 to start. I'm going to write the number 16, and then I go ahead and draw my lines. And I think of, okay, what are 2 things I could multiply to get to 16? So I'm going to multiply 8 times 2. You don't have to write the times thing there, and sometimes I will and sometimes I won't. And then I think, okay, what goes into 8? Can I divide anything into 8? And I can. I can divide both the numbers 4 times 2 into 8. But nothing to 2 because 2 is a prime number. Only 1 and 2 goes into it. All right, and then, well, there's another prime number there, but I could still divide 4 out. And we'll say 2 times 2. Good. So these are all the prime numbers that make up 16. Now, oftentimes they'll ask you to write a multiplication equation to show those prime numbers. And what they mean by that is that you write all of these prime numbers. So I sometimes just go ahead and circle them so I remember. I have all these prime numbers at the bottom. And in this case, I have 4 2s. And then I write 2 times 2 times 2 times 2. And then that would be the factor tree and an equation for 16. All right, let's try another one. Let's try number 24. So I write 24. Draw my branches. And I have to think of something I can go into 24. I'm going to do 6 times 4. And I got to think, okay, is there anything that goes into 6? And yes, both 3 times 2 goes into 6. And 4, it can be broken down again as well. Do 2 times 2. All right, so the prime numbers that make up 24 are 3, 2, 2, and 2. So if they ask you to write the equation, the multiplication equation, I would do 3 times 2 times 2 times 2. So you do it for each one at the bottom of the branches. You don't want to write any of the composite numbers. So I wouldn't want to write 6 or 4 because something could still be divided in there. I only want to write the prime numbers that are at the end. All right, so now you've seen me do a couple of examples. I'm going to have you practice a couple of examples. So this one says make a factor firework for the number 56. So go ahead and work on that. And then I want you to go ahead and write an equation that shows 56 as the product of the prime numbers. So remember how I showed you how to multiply it at the end? I want you to go ahead and do that and see what you get. All right, let's see how you did. So I'm going to go ahead and take this and let's see. So for 56, you could have done 7 times 8. Now remember, you could have done something different, which would have been fine, because you'll still get the same prime numbers. And then for 8, I'm going to do 2 times 4. For 4, I'm going to do 2 times 2. I'm going to go ahead and circle all my prime numbers here so you can see it. We've got 7, 2, 2, and 2. I'm going to go ahead and write the equation out, or show you what you would have gotten when you wrote your equation out. You would have gotten 7 times 2 times 2 times 2, which equals 56. Now, if you're going to use your equation to help you solve this, you're going to try to find something that equals 14. So two things can multiply together to get to 14. So right away, I see that I can do 7 times 2 is 14. And then I'm going to times the rest of the stuff together. So in this case, I have 2 times 2, which is 4, equals 56. Now the cool thing is, if you remember back to when we did our fluency chapter, we learned that we can switch all of this around. I'm just going to rewrite this. So I'm going to say 56 divided by 14, which is what they originally want us to do, equals, guess what? It equals that 4 that we found. So sometimes you can use the factor, the prime number multiplication to show, help you solve other problems. All right, next we're going to be talking about factors and multiples. A multiple of a number is a product of that number and a counting number. So you'll know multiples here as soon as I show you some. You're like, oh, I know what that is. It says, what are the first 5 multiples of 4? Explain your method. So the multiples of 4 are 4, 8, 12, 16, 20, right? It's all the things when we multiply, it's our 4s. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, and we could keep going, right? Now it says write the first 10 multiples of 8. So this is just knowing your 8 count bys or your 8 times tables, right? So you're going to start with 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, right? And I could do 8 times 1 is 8, 8 times 2 is 16. I could do all of those, but that's what the multiples are. They're all the different things we multiply 8 through, 8 in this case up to 10. Now, this one says, give 2 reasons why 21 is a multiple of 7. Okay, so how can we prove that they're multiples? Well, we could say that 21 is named when we skip count by 7s, right? We go 7, 14, 21, so it's named. Or I could say 7 times 3 is 21, or 3 times 7 is 21. So we know it's a multiple of 7. Okay, again, a multiple is that number when it's multiplied by 7 is a multiple of that number. Okay. Let's see. Let's skip ahead a little bit. I wanted to look at this one. It says, is 50 a prime number? Explain why or why not. So remember our definition. A prime number is a number that only one and itself can be divided into it, and a composite number is a number that other numbers can be divided into it. So what do you think? Is 50 a prime number? Yes or no? If you said no, it's not, you're right on, because there's a lot of numbers that divide into 50, right? 25, 5, 10, all those numbers divide into 50. All right, so that concludes our lesson today. We talked about prime numbers and we learned how to create factor fireworks. Great work.